Hi students, this is Callie Daniels. In this video, we will consider formulas and additional applications from geometry. So let's dig into some examples. In example 1, we want to find the value of the remaining variable in each formula. Part A, we have P is equal to 2L plus 2W. This is the formula for the perimeter of a rectangle. So just to fill in some background here, remember that perimeter is distance around an object. So if we wanted to fence a rectangular yard, we would use perimeter. Now in a rectangle there are 2 lengths and 2 widths. So for this rectangle we know the perimeter is 126 units and the width is 25 units. So we're going to substitute those two values and then solve for L, the length. Here we go. 126 is equal to 2 times the length plus 2 times the width, or 2 times 25. And here we're just going to then solve for L, the length. 126 is 2L plus 50. If we subtract 50 from each side, 126 minus 50 is 76. And then dividing by 2 gives 38 for that length. So our length is 38 units. And if you wanted to just check your work here, if each length is 38 and each width is 25, then adding the distances around 25 twice and 38 twice will give you that total of 126. In part B, and here, the main focus is we're just getting used to working with formulas, substituting values, and solving for an unknown. And these are linear applications because we end up with an equation with a variable to the first power. Now in part B, we're given the formula A is equal to 1/2 h times, in parentheses, b plus b. Well, this is the area formula for a trapezoid. Trapezoids have 2 parallel bases and then 2 non-parallel sides. We usually call uppercase B the longer base. We know it has a length of 31 units, don't we? And lowercase b is the shorter of those parallel bases. And just giving you some background here still, h is the vertical height between those bases. All right, so this is an area formula. Now area is different from perimeter. Perimeter is distance around an object, fencing a yard, while area, is this surface area of an object. So if we wanted to color the area, or if we wanted to paint a trapezoidal sign, then we would cover that surface with paint, wouldn't we? So this is an area kind of formula. Just recapping, okay? But what's our goal? We're going to substitute values. A is 75, lowercase b is 19, and capital B is 31. Let's substitute. 75 is 1/2 h the height times, in parentheses, 19 plus 31. Now we're just going to solve for that remaining variable, the height. 75 is 1/2 the height times, I'm going to go ahead and add 19 plus 31. That sums to 50. Next, I'm going to use the associative property of multiplication. We can multiply factors in any order that we choose. So I'm going to multiply 1/2 times 50. Half of 50 is 25. So 25h is equal to 75, and last, let's divide by 25. 75 divided by 25 is 3. The height is 3. And just thinking out loud, if you wanted to check this area formula, is the area 75 truly equal to 1/2 times the height of 3 times the sum of the bases, 19 plus 31? You don't have to check these, but just again, thinking out loud, giving you some background here, trying to help this make sense for you. Again, I'm going to multiply in the order that's easiest. Half of 50 is 25, and 25 times 3 is 75. So if the height is 3 units, then we will get an area of that trapezoid equal to 75 units. Now in example 2, we're going to pump up the volume here a little bit and solve a problem. Okay. Here we have a farmer. He's got 800 meter of fencing material to enclose a rectangular field. How about we draw a rectangular field? We know that the width of the field is 50 meters less than the length, and we want to find the dimensions of the field. Okay, so if L is the length, then the width is 50 meters less than that. So it's the length minus 50. Okay, 50 less than the length is L minus 50. Now let's go ahead and assign our variable. We've got a good picture that we can use. We want to find the dimensions. I'm going to let L equal the length of this rectangular field. Now we want to fence the perimeter. Okay, so looking back up here at example 1 part A, our perimeter of a rectangle is 2 times the length plus 2 times the width. Okay, because we're just adding around the figure length plus width plus length plus width. Okay, so now as we write an equation, I'm going to work off of that perimeter formula. And let's substitute the values that we know. We know that we're working with a perimeter of 800, so substitute that for P. We don't know the length, and we don't know the width, but we can at least describe the width using our single variable L, L minus 50. And what this allows us to do is write an equation with a single variable. Now we can solve for L. 800 is 2L plus, distributing 2L minus 100. So 800 is equal to 4L minus 100. Add 100 to each side. 900 is 4 times L, and let's divide 900 by 4. That's 225. So the length is 225 units. That's 225 meters. Let's go ahead and check this result. So if the perimeter is 2 times the length plus 2 times the width, then is it true that 800 is 2 times 225 plus 2 times the width? Now we do actually need to determine the width as well, don't we? Okay, we know that the width is the length minus 50. So it is 225 minus 50, or 175 meters. Okay, make sure that we answer the question asked. Length 225, width 175. And we're checking that. Well, 225 times 2, that's 450. And 2 times 175 is 350. and together those do indeed sum to 800. Okay, so making sure that we stated our answer. Length is 225 meters and the width is 175 meters. Moving on to example 3. Here we want to solve each problem involving vertical or straight angles, and we're going to refer to the figures and find the measure of each marked angle. Now in picture A, we have a couple vertical angles. When two lines intersect, these angles opposite of each other are called vertical angles, and vertical angles have equal measure. Why is that? Well, this angle to the right, 2x minus 21, is a supplement of this angle to the top that's adjacent to it. And so is the angle 5x minus 129. It is also supplementary with that angle. And if these two angles are both supplementary with that, then they must have the same value. So vertical angles have equal measures. We're going to use that sentence to now set these two expressions equal. 5x minus 129 is equal to 2x minus 21. And let's solve for x. Subtract 2x from each side. 5x minus 2x is 3x. And let's add 129. Well, positive 129 minus 21 is 108. And dividing 108 by 3 gives 36. Now don't stop there. We want to find the measure of each marked angle. We've solved for x, but now we want to substitute that into our expressions. 5x minus 129 is 5 times 36 minus 129, and let's compute 5 times 36 minus 129, 51 degrees. Now let's evaluate our second expression, replacing. So here we have 2 times 36 minus 21. 2 times 36, that's 72. And minus 21 is going to give 51 also. So did we find the measure of each marked angle? Yes. Each marked angle measures 51 degrees. And we don't need to check this because it's checking itself. We know that vertical angles have equal measure. And notice they do have equal measure. They're both 51 degrees. Now in figure B, we've got a couple of expressions representing angles that are supplementary. Okay, they form a straight angle, okay, or a straight line. And so we know that in a straight angle or straight line, there's 180 degrees. Okay, and so as we add these measures, 10x plus 7 to 7x plus 3, we will obtain 180 degrees. Now we solve for x. Combining your like terms, 17x plus 10 is 180. Subtract 10 from each side to get 17x is 170. Divide by 17 to obtain 10. X is 10, but don't stop there. We want to find the measure of each marked angle. Okay, our first marked angle is 10x plus 7. In other words, 10 times 10 plus 7, as we replace x with 10, and that's equal to 107 degrees. In our second expression, 7x plus 3, replacing x with 10, 7 times 10 plus 3, and that is 73 degrees. So our marked angles measure 107 degrees and 73 degrees, and notice that those are supplementary. If you add them together, they form 180 degrees, so we feel really good about our work there. Lastly, in example 4, here we're just going to work with formulas and solve for a specified variable. Y equal mx plus b is our slope-intercept form of the equation of a line, and we're going to work with that extensively in chapter 3 of this course. Okay. So we want to solve for x. Let's first subtract b. Y minus b is equal to mx. Remember, we're trying to isolate x by itself on one side. So next we need to move that factor m away from it using our multiplication property, but here I'm actually going to divide each side by m. And write x on the left. X is y minus b over m. Or you might also see this answer written x is equal to y over m minus b over m. Just writing that as two separate fractions since each of those terms in the numerator is over m. Notice that we didn't combine those terms in the numerator because they're not alike. They have different variables. Lastly, part B. This is the formula that converts degrees Fahrenheit to degrees Celsius. You don't have to memorize this. We want to solve it for f. So we're going to start here by multiplying each side by the reciprocal of 5/9, which is 9/5. 9/5 c is equal to 9/5 times 5/9 times f minus 32. Multiplying reciprocals, the product is 1. This gives 9/5 c is equal to f minus 32. And keep in mind that we're solving for f. We want to isolate that variable on one side by itself. So we've got one last step. Let's add 32 to each side. So 9/5 c plus 32 is equal to f. And I just like to see that Fahrenheit written on the left. You don't have to do this, just it's what I like to do. Fahrenheit degrees is equal to 9/5 times Celsius temperature plus 32, and we have solved that equation for f. All right, so on this video we've worked with formulas. We're still solving some applications, and best of luck on these.